Welcome to Introduction to Engineering Design. We're back in Module 4.1c, and we're working on analyzing our data in Excel from our puzzle cube mass. With that said, what I'm going to do is go ahead and input the data from my original measurements into my Excel datasheet. And I don't really need to record the color of the piece because it doesn't really matter. So I'm just going to record the number of cubes and the relative mass. So first I've got a 5 cube, 5 cubes and 22.5, 5 cubes, 22.6, 6 cubes, 27.2, and a 6 cube, 27, and a 5 cubes and 22.4. With this data entered, what I can do is go ahead and create a scatter plot. So I want to highlight my data first, click on Insert, and come up over here into where it's the chart area. And I'm going to insert a chart. You'll see that these are different style of charts. If you hover over and let them drop down, it'll tell you what it is. We want a scatter plot. So I'm going to click on the scatter plot, and I want the very first selection here. It's a scatter plot without any lines in it. Click on that and it just drops in. I can grab it and drag it and move it around. So that's my scatter plot. Next part of the exercise tells you to add some chart elements. That's this upper left hand corner. You'll see where it says add chart element. Click on that drop down and I can add different things. So what I want to add is I want to add some titles to my axes. So I can click right here on more title on title axis options and I can add them. Or what I can do is just come here and add them as elements. And I'll add them as elements. I'm going to add a primary horizontal and a primary vertical. So primary horizontal first, and primary vertical. I can name all of these axes. So let's go ahead and call this puzzle cube mass, or puzzle cube. And let's start over here and say number of cubes on our x-axis as our independent variable, and the mass in grams as our dependent variable. Now looking at this, you can see that it's kind of an odd looking chart. What I really want to do is start at 0 and 0. So I can arrange and I can alter these by formatting the axis. And over here on the right hand side you'll see that I can go with a minimum of 0, and I'm going to extend that from 0 and I'm going to go out to, let's say I had a piece that was 8 cubes. And now I've changed that axis. Similarly, I can select my my y-axis here and I go from 0 to 30. Let's go up to 35. Now I've fully changed my labels and my axis scale. Let's add a chart element. What I want to add is a trend line. And we know from our earlier discussion this is a linear chart. I'm going to go ahead and add a linear trend line, and you'll see that appear, and it just connects the two dots. And what it does is really averages. My data points are really close together, so you can't see that. But what I can do is come into trend line and look at more trend line options. And at this point, I can do a couple things. I can set my intercept of my trend line equal to 0. I know it's that because I know that a 0 cubes weighs 0. I can display the equation on my chart. There it is, y equals 4.5082x. And then I can also extend a forecast backwards and forwards. So let me go backwards 5 periods, or forwards 4 periods, backwards 5 periods. And now you'll see my chart, and it looks very similar to the one that I drew by hand. So there's a forecast forward and backward. You'll see that my data fit very nicely on that chart, and it looks almost identical to what I drew by hand, except Excel did a little neater job, a lot quicker. So let me drag this over. and you can see a very similar chart. So that's how to enter the data into Excel. Thanks for watching. That's 4.1C, mathematical modeling, and we're looking at analyzing our cube data.